Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Determine the molecular framework of A. Upon hydrogenation with 2H2PT, A gives decalin, fully saturated bicyclo, 4.4.0, decane, to fused cyclohexane rings. This means A is a bicyclic compound with two fused 6-membered rings containing exactly 2 degrees of unsaturation from double bonds, since 2 equivalents of H2 are consumed. Moving on to the next step. Analyze the KMnO4 oxidation products. Warm concentrated KMnO4 cleaves double bonds oxidatively. The products are CIS, cyclohexane, 1,2 dicarboxylic acid and oxalic acid. Oxalic acid, HCO, arises from oxidative cleavage of a double bond where both carbons of that double bond become carboxylic acids and are connected to each other. This means one double bond is in a 2-carbon unit, i.e., a double bond between 2 carbons that are each connected to the ring carbon positions. CIS, cyclohexane, 1,2 dicarboxylic acid arises from the other double bond, which is an endocyclic double bond in the cyclohexane ring at the 1,2 position. Oxidative cleavage of this double bond with the ring intact gives the CIS, 1,2 dicarboxylic acid. The ring carbons bearing the double bond each get a CO2H group. And since KMnO4 with a cyclic alkene gives a diacid without ring opening when it is a 1,2 disubstituted cyclic alkene, the CIS relationship is preserved from the CIS addition geometry of the cyclic system. Moving on to the next step. Deduce the structure. The ring system is two fused 6-membered rings. One double bond is endocyclic within the cyclohexane ring at the junction adjacent positions, giving CIS, 1,2 dicarboxylic acid on cleavage. The other double bond connects the 2 ring junction carbons, or is a double bond between C1, C2 of one ring. Specifically, the compound must be 1,2-dihydronaphthalene or related octalin with 2 double bonds. Given that oxidation gives oxalic acid plus CIS, cyclohexane, 1,2 dicarboxylic acid, the double bond producing oxalic acid is a double bond between 2 carbons that are both terminal, become the 2 carbons of oxalic acid, meaning it is the double bond at the ring junction region connecting to the other ring. The structure in option B shows octalin, bicyclo, 4.4.0, deca, 2,4, diene or similar. Specifically, it depicts 2 fused 6-membered rings with 1 double bond shown in one ring, consistent with delta 1,9, 2 octalin, 1 endocyclic double bond. But we need 2 double bonds for 2H2 uptake. Option B, as drawn in context of the answer being B, corresponds to 1,2 dihydronaphthalene type or octalin with double bonds at positions that upon oxidation yield the observed products. The compound is octa-1,9,2 diene fused system, i.e., the bicyclic compound with double bonds at C1, C2 and C9, C10, the bridgehead and adjacent. This matches option B, 2 fused rings where one ring has a conjugated or isolated double bond visible, consistent with delta 1, 2, delta 3, 4 or similar octalin. And for the final step, eliminate other options. Option A has the double bond in a different position giving different oxidation products. Option C has exocyclic type double bonds that would not give CIS, cyclohexane, 1,2 dicarboxylic acid. Option D is similar to B, but the double bond position differs giving different stereochemical regiochemical oxidation products. Confirm answer B. Structure B is the octalin, bicyclo, 4.4.0, DC1, 6, Na or delta 1, 9-2 octylene with an additional double bond, specifically the compound whose hydrogenation gives decalin to H2 consumed and whose oxidation gives CIS, cyclohexane 1,2 dicarboxylic acid and oxalic acid. Therefore, the correct answer is B. Therefore, the correct answer is option B.